Okay, today I will demonstrate how to make an emerging bowl. So it's basically a bowl that's halfway out of the blank and halfway still in the blank. And people ask me, when people that are not wood turners ask me how I made it, I tell them I just sharpened my gouge on one side.
Sharpen what?
I sharpened my gouge on just one side.
One side.
Yeah. Okay. So the basic idea is I'll start with something close to a 4x4, and on this one I've split it in half and then put a paper joint in there. So I took the original piece of wood, smeared wood glue all over it, and then I just used computer paper, laid that up against the side and put the other block of wood that had been coated in wood glue, I used Type Bomb too, clamp it, and that gives me a joint down the middle that I can split. And when it comes open, it's as flat as it originally was. So I can split this open without removing material. So that's where I start. That's what I have mounted in the lathe. Okay. And to just give you a quick rundown on every step, every important step along the way. So I start off with some kind of, tend to call it a 4x4, but it's any kind of rectangular blank that you want. Okay. I turn a tenon on it and mount it in my 4-jaw chuck. On the other end, I'm going to turn a hemisphere, or half a sphere. I split this open along that paper glue joint. I find the center based on this edge. So the center point of the tailstock, the live center on the tailstock, will help me locate that point. I'll mount it sideways. Turn this hemispherical bowl shape. And if I have everything lined up, this edge will have the same width and the bowl will have the same thickness all the way through. And then when I come to make the final cut here, this cut will exactly follow along that cut. The trick to doing this is turn an accurate hemisphere to begin with. Leave this on the lathe. And then split it open, accurately locate this point, and that means everything will come out just perfect. I've never done one like that.
Still working on it.
Okay, the one that was in the raffle, if you look at the rim, you can see some imperfections. And that means I didn't get the hemisphere just right, and I didn't get that center point just right. This is the second one I've made, and I concentrated on getting everything as good as I could, and this one looks pretty good. The main imperfection is a slight, you can feel it easier than you can see it, but it's visible, a slight mismatch over here, and I moved the wood out over here and moved that out on the table saw. I'll pass this around. This is the next one I made. Same, it was the corresponding piece of wood. When I used a center punch to line that, to mark that hole, the grain forced it over a little bit, and I went ahead and turned it like that, and now you can clearly see the effects of that mismatch. The wall thickness is different here than it is over here, and you can see it. It's not something you have to feel, and you can see the size of that mismatch. So that's one of the things I have to be aware of, is make sure I get that center accurately marked, accurately center punched, and then accurately lined up on here. Now once I get the bowl turned, then I come around and I clean up this edge and then cut some of this wood off. And then I can cut it off the lathe, chop this off with the saw, and I'm done. I'm going to start with it mounted like this and turn the hemisphere, split it open, remount it here, turn the bowl and face this off, and then that's it.
That must be the exciting part. That must be the exciting part.
Which part's that?
Facing off the,
It can get exciting, yeah. It depends on how it goes. You want to, let's see, this is the second one that came out pretty good, and this is the one that I missed my center punch. This whole idea is based on a sphere. And here's another thing that you can make. I don't know if this is going to ever show up right, but it's a lattice work.
yeah, it shows good on that.
It's a lattice work. Basically, this is my first take on Hans Weisflog's work. He's a German turner that does some beautiful work. And I want to learn how to reproduce some of this. You turn a grid pattern, you flip it around, turn the grid pattern, and you form a mesh. How about I pass that one around? That is based on exactly the same idea that
Amazing.
this is. You turn a sphere from two different directions, and if you line everything up properly, that's what you can come up with. If I take it one step further, this is exactly the same idea. I start with the 4x4, turn it between centers, but I only turn this much of the sphere. That defines the center point in the radius, and then I turn it sideways, line this up so that this point goes through the center of the sphere. So when I turn this portion, the spheres match. I rotate it, do it again, rotate it, rotate it. If you line everything up, you can come up with this. It's the same idea. If you can locate the center of a sphere and determine the radius, then you can turn that sphere from any direction you want. So two things you have to do. As far as a wood turner is concerned, if you can get the center line of your lathe running through the center of that sphere, all you have to do is make sure you get the radius correct, and you can do this from any angle that you want. That's how Hans makes some of his really, really cool stuff, I think. That you turn a ball from different angles, but you always hit that center, and you always hit that radius, and you can do some really cool stuff.
I was just proud you could say his last name.
I looked at Wiesflog in German, it's a bus. I had to look it up online. Okay, so let me get this set up real quick. I have a cedar blank, and I've cut it so it's basically two 2x4s that are slapped together with a piece of paper in between. This is cedar, and because I had the center, the live center, leaving a divot in there, I've marked the line. Can y'all see that line?
I'm going to zoom in.
Okay. Actually, I think for most of the demonstration, you can zoom in and.
How's that?
Okay.
Come over here a little bit.
There we are.
Okay.
Okay. So I've marked the line of material I want to remove, so I cut that divot out. And now I want a 2.5 inch diameter hemisphere, so I've got 1.25 inch space here. And then the rest of this I'll just leave rectangular. Okay. So let's get started. The first time I used a paper joint, I was afraid to turn the lathe up very fast. But I think that paper joint is about as strong as gluing two pieces of wood together. Is that pretty much true? So a lot of the fear that I had of using a paper joint was unfounded, provided I had the two surfaces flat and they make well. Okay? Just like gluing wood, they have to make well.
It is wood.
Basically, yeah. first thing I want to do, remove enough wood on the face so that the divot left by the center point can be cut away easily. Okay, the next thing I want to do is turn a 2.5 inch diameter cylinder here. I set my calipers to 2.5 inches. Maybe just a hair generous.
Disappearing switch.
Okay. Y'all see that piece of wood fly over my shoulder? If y'all have never done this before, when I buy these calipers, they tend to have a sharp point. I'll round that off. I round it in this direction and in this direction so it can't catch on anything. And then before I ever stick it on a piece of wood, I make sure it's round. See how that's bouncing? I won't stick these calipers up against there because it'll grab it and can throw them in my face. See how smooth that is? When I get the wood that smooth, then I'll put the calipers up there. And a real light touch on the calipers. Stop. I'll show you what I'm doing. So I'm about to turn the hemisphere out of this, and this line represents how far I need to cut back. This surface will be visible in the final product. So I need to make sure at this stage that I get a good clean cut on that surface. Over here I just hogged out material, and I have a little bit of tear out, but it's not a problem. I'm going to cut that away. This surface needs to be clean. I'm going to have to clean that up a little bit before we finish. That's the first step, is to get me a cylinder that I can work with. The next step is to turn this cylinder into a hemisphere. And some people can eyeball that and get really, really close. I can't. So there's a trick. Now, first time I saw something like this, it was Al Hockenberry in Colorado. Let's say I start with a rectangle of wood. If I measure out about 0.3 times this diameter and lop that off and do it all the way around, it'll convert that square to an octagon. And a lot of times I'll just mount that on the lathe and turn it. I can also take this distance, which is the same as this distance, divide it into fourths, connect the outer points, lop those ears off, and that's how close I am. I think you can see it even in the back. That's how close I am to a circle.
So, the 0.3, what are you multiplying it by? The diameter?
The diameter, yeah. So if I call L the diameter that you're looking for, or the width of the board, in this case, L is going to be 2.5 inches, the size that I want that hemisphere to be. If I multiply 0.3, or actually 0.2929 times L, and measure from this corner over that far, and measure this corner over that distance, and lop those off, that gets me real close to the edge of that circle. And then if I take this distance and divide it into 4, and then lop off, and do that for each one of these segments, lop that corner off, I'm really close to having that circle formed. Okay, 2 measurements. One of them from corner to corner, the other one divided by 4 and connect the adjacent points. And all I have to do is make a straight cut between those, and I come up with a half circle that's pretty accurate. And now all I have to do is eyeball and come around and make a single cut here, and I'm really close to a hemisphere. Okay, this is Hemispheres for Dummies. That's why I like it. Okay, so that's what I'm about to do. Okay, first thing I need to do is verify I'm about 2.5 inches. I need to take about 40 thousandths off.
He's taking 20,000 something.
I heard that.
Well, only take 20 off one side, Jim.
Okay. Who took off with my bow gun? Okay, that's good. I'm not going to tell you what it reads because y'all laugh. Take 40 off of this. Every now and then I get lucky, I was within 4 thousandths of what I was shooting for, which is ridiculous. So if I take 2.5 inches times 0.3, that's 3/4 of an inch. Or if I want to get a little closer and multiply it by 0.2929 the way I'm supposed to, that's 7.32 inches. 0.732 inches. Mark here. Put a mark there. Okay. So I have my 2 marks. Now I just want to make a straight cut connecting those 2 lines. I want to compare the distance I have from my cut to that line and make it the same as the distance from my cut to the line here. And that tells me I had that angle correct. And now I can just sneak up on it.
Would it be okay that I could come up and just take a look and see where you are? Could I come up and take a look and see where you are right
Yes,
now?
you can.
Well, not him.
I was talking and not paying attention. I put 0.8 instead of 0.732. I'm about to be-
I can see that flaw.
Okay, so I just messed up. What I'm going to do is cut this tip off, redo my measurements, and try to get it right this time. I want to say I can't believe I did that, but yeah. I've noticed, especially since COVID, if I start talking, I quit paying attention to details, and I have no idea why that is. So now I've got to figure out how to make my marks and get them right. So if I eyeball,
You gotta remember, Jim's got a PhD in quantum physics. So that's kind of why he's a little bit
Little picky.
Yeah, he's special.
I just cut a template. Stick it up there until it gets right.
that's close enough.
Close enough.
Okay. I went stupid and then got lucky. It all works out. So this is about an inch. If I divide that in 4 pieces, that's a 1/4 inch. And now I want to measure a 1/4 inch over here. A 1/4 inch down here. Part of the reason I want to develop a technique that works for me is I want to reproduce Han's work. I have a folder on my computer of basically files of work from other people that I want to copy for the learning experience. And after I turned the first of these emerging bowls, I realized that some of the concepts were exactly the same.
Can I ask a question?
You may-
Turn it off for a second. Would it be easier there if you angled the tool rest so that you didn't have so much of a distance?
Yes,
Like that.
yes. You notice I spun it by hand and I did it slow. I've learned not to knock the tips off. A lot of times I get excited, I get in a hurry, and I take this and I whip it around, and then I damage some delicate thing that I'm working on. I finally learned, turn it slow. Okay, so now I need to connect these two lines. With a straight cut. Okay, now these two. Okay. It's hard to see from this angle, but it's pretty close to a hemisphere. Can you see how close it is? Now I just need to lop these ears off, and I'm going to be even closer. And it may turn out that for your purposes, that might be close enough, that you don't have to do any more.
Is there a benefit to sanding them versus lopping them?
I avoid sandpaper when I'm trying to do accurate work because because of the variation in the wood hardness. You will never sand it round. You will always take it out of round. So I want to do as much as I can, either cutting or scraping. And in sandpaper, for me, on this kind of project, is just to get the surface finished the way I want. Other projects, I use sandpaper like a crude gouge. Not this. If I'm shooting for a particular dimension, I won't use sandpaper except to get the surface finish I want. Need better contrast. So put a piece of yellow paper underneath. Okay, so I made a couple of templates. One of them is a 2.5 inch diameter hemisphere. And I'm off quite a bit down here at the bottom. I made a smaller template that fit on here. And can you see?
Yeah, and this,
It's hard to see, but I can see a large gap, say a 32nd of an inch.
You can see it up above, Jim. That looks good.
Oh, can you see it over there?
Yeah.
So, templates used to drive me nuts because you had to get pretty close to get it right. I watched a video by the Papa 1947, YouTube, and he coats his templates with crayons. I'm using pencil, rub it, and now I can see where I need to remove material. Can y'all see that? Okay. Can you also see this? This is a fascinating thing for me. I have pieces of this. This is a tree that used to grow by my mom's house. And there are places where you come up with a perfect square white inclusion in it. And I've never seen that perfectly square type thing. If you get the wood orientation right, it's really fascinating to me. So between these two lines, I need to remove a little material. I'll just use a shear scraping technique to remove just a little. Okay. So I need to cut the same place and remove even more. Keep touching it. I tend to get impatient when I do this, and that's a bad idea. So now I have just a little space right here. Okay. That's pretty good. So now I'm going to take this small template and roll it over. And it's pretty clear where I stopped. So I'll continue making these marks and carrying that cut around. The hard part for me is to be patient with this. I need to cut a little bit more off of here, and I can finish off that hemisphere. not comfortable getting this tool up into that corner, so I'm gonna just use a parting tool. Take little tiny shavings. I'm gonna call that good enough. I should take just a tiny bit more, but I'm sure y'all are tired of watching this, so.
It's not gonna be right.
Okay, so that's the first step, is to turn the hemisphere. And using the techniques that I've done, if I take my time, I can normally get this right pretty quickly. Now, I have to be it's slow and tedious at the end where I'm using the template. But if I use the small template and cut off any of these marks, then I can get a really accurate start on it, and then this final template will tell me that I've got it right.
So is this the point you would sand?
This is where I would sand. At this point, I would sand and maybe even finish the hemisphere and this face. Or if I wanted to decorate this face with some kind of wave or just whatever kind of decorative stuff, chatter work, now would be the time to do it.
What do you sand with?
With this, I would start at about, I'd probably try to start about 320 if I could. Because I don't want to sand, because sanding will change the geometry. So I want to just sand enough to get the surface finish I want, but not change. I don't want to remove a lot of wood. Now out here, it depends on what you plan on doing. I've got some pretty bad tear out here.
I can only wish to have that bad a tear out.
And I would try holding a block out here, but be careful because it's going to bang on you, and you don't want to damage your hemisphere. But this is one technique I've tried. Do you have any questions about this stage of the operation? Yes, sir.
Are you doing your templates like, you know, perfectly, that perfect, cutting them and sanding them, like,
Is that plywood?
I mount a piece of wood, faceplate, piece of plywood or whatever, and then I hot melt glue a piece of thin material. And then, so I hot melt glue it out here and then turn my circle. Or a Forstner bit, if you're going to work with, you know, if you had a 2.5 inch Forstner bit, that would be a simple way to do it. I don't have one that size, so I just hot melt glue it to the back of the plate and then turn that circle to whatever accuracy I want.
What is your template made out of? Is that quarter-inch ply?
It's cardboard. Yeah. Scrap, construction scrap.
I don't have cardboard.
I used to use cardboard, and I would, just over time, I'd wear it out. And then plus, you can't really press on it to get the crayon or pencil lead. So I've gone to harder materials, and that's worked well for me. Now, here comes the fun part. I need to split this guy in half. Stay. Okay. The trick I try to use when I'm splitting these apart is some of this is going to get cut away. That's where I want to start my chisel. That way, if I mess something up and leave a big divot, I'm going to cut that off anyway. So want to get this chisel set so that it's in that glue, or in the paper. We move over to this other edge. So that's what I end up with. Scott, you want to catch this?
I'll try.
If you take a look, you can see where I got in a hurry and didn't finish off getting the hemisphere correct. I'm going to pay for that in a little bit. But here's the deal. I've learned that a lot of this stuff doesn't matter. I turned one of these and it's a little bit crooked, a little bit this, a little bit that. If you roll the edge over on the inside and the outside of that bowl, it hides some of that. And 90% of the people you hand it to do not care about those kind of mistakes. Okay, so now I need to find the center of that hemisphere on this face, and that's supposed to be a 2.5 inch diameter. It's not even close. This says 1, 2. I'm gonna set this to 1 1/4. Let's set. I watched over a dozen YouTube videos, and everybody seemed to have a different way to find the center. And this has worked well for me for all of these. So I'm shooting for a 2.5 inch diameter hemisphere. I set this to 1 1/4 inch, whatever the radius would be, and then just make marks. And that tells me where to set. That tells me where that center is. And this center is going to be as accurately located as your hemisphere is. Okay, so there's the center. Let's see how close I am. Pull this back a little bit. Can you see that line?
No. On the big screen you can.
Yeah,
It's got a little glare.
sometimes there.
Right there.
You get kind of glare.
Okay. I'm accurately following the edge of the hemisphere up to this point. And then you can see I have a flat spot, and that's going to show up. But that's small enough I can correct it with sandpaper, so I'm not going to get overly excited about it. Now I need to be able to mount this on the lathe. There's a number of ways of mounting this on the lathe. Some people use, I've seen people use screws. Some people use a paper joint and glue it to a faceplate. I've been using hot melt glue, and I've always been leery about how strong that is. But I've learned that if I sharpen my tools and take a light cut, it's plenty good. That's running fairly well.
I've actually done an Instructable, if you go to Instructable.com, on how to use hot melt glue to do that.
Do with your mallet.
Christian, do you use the hot melt wood glue or even the regular stick is fine?
I went to a yard sale and got a box of it about that big. It's got about 500 little sticks, and that's what we used. It worked good. You
Okay.
just got to be sure your glue is really hot, so it flows.
When I made this center point, I didn't just punch it with a hammer. I used my hand to make sure that center point stayed centered. And this is the mistake that I made on one that I've been passing around, that I passed around. So now I'm going to clamp this. Get this out of the way. As far as I can tell, that's running true.
Yeah.
So now, let's glue it on.
And you can see he hasn't put it between the two pieces. He's putting it on the outer edge of the piece. If you put it between it, when you turn it, it'll get hot and fall off. Ask me how I know.
What, you don't want it just on the very edge, outer edge only?
Yeah, you just want it on, like he's doing it right there. Just you can see it
I
up
put
there.
it on 3 edges. And now, I should have a triangular piece of wood. Looks exactly like that. Put that here. Glue it on.
As a support?
Yeah.
Yes. As I turn this, some of the force is going to be out here, and it's going to want to tip that over, and I want to counteract that. If I was confident, I may not have to do this. Because if I take a light cut with a sharp tool, I'm not going to put a lot of force on there. But it cost me a piece of wood and, a 1/4 inch of hot glue. So I really can't see any point in not doing it now. Five minutes.
Talk about this.
Oh, yeah. Okay, how to get a hold of there with this threading. I live in Knox City and I go to Monday at the junk store, and there's a whole bunch of farm equipment and oil field equipment, and I bought a used 1" 8" threading tool that had been beat up. You can see the pipe wrench marks on it. And I could thread wood with that well enough to put it on my lathe. But it chewed up some kinds of wood, bad enough, softwood, to the point where I didn't want to use it. So I went and bought a 1" 8" bolt. And I took a Dremel tool and just made a cut along here and cut a flat, and did that in 4 places. Then I came and cut vertically in 4 places, and then I tipped the tool just a little bit and cut along here to give me a cutting edge. I did that in 4 places. And then I mounted this between centers on the lathe and took a file and rounded this off and made a homemade threading tool, and it works beautifully. So if I have a 2x6 lying around, I'll cut it square, lop the corners off like I showed you with a piece of paper, put it on the drill press and drill a 7/8 inch hole through there. Then I mount this on the drill press. I mount a 1/4 inch or 1/8 inch drill bit in the drill press, center this on the drill press, center this on the hole, and then just screw it down by hand or with a wrench, depending on what kind of wood I'm working with. That keeps everything straight. Then I put this in a vise and turn the board and thread my way all the way through. And now I probably do 4 or 5 at a time. So now if I want to do something like this, I just thread this on, face it off, and I'm ready to go. And if I want to cut it up, glue on it, screw something to it, cut it with a saw, fine. It's a tube, it's a 2x6. I can mistreat it and throw it away without too much effect. And it turns out, for some of this spherical work that I want to do, it works beautifully. It works beautifully because if I want to align a ball on the center of the lathe, if I cut a cone in here, and it doesn't matter what kind of cone, it can be straight wall, it can be a little bit goofy this way, a little bit goofy that way. When I put the ball in there and spin it and get it seated, the center of that sphere will be aligned with the lathe. So I can drill a hole here, rotate it, drill a hole here, and I know that it's on line always, because you take a ball and you put it on a cone, the center is always going to lie on that center line. This, by the way, is how I designed the golf ball. You see the red dots? That's how I did the golf ball. The golf ball is the same idea. This, I've made bottles before, and I hollowed the bulbous part from the bottom, put a plug in it. But I was fooling around with this. I was fooling around with spheres, and I thought, what if you drill a whole bunch of holes into it and then plug them? You can make something that reminds me of I Dream of Jeannie. Yeah. Everybody's laughing, knows how old I am now.
We're with you.
Yeah. Same.
And so you can make a bottle with no hollowing.
You know that actress is still only 30 years old?
Yeah.
I saw her just the other day on TV.
So again, you can just take a sphere and drill a bunch of holes in it and hollow the sphere. And it's the same concept as what I'm doing here. I'm turning a sphere from different directions, and all I have to do is get the center of the sphere on the axis of the lathe and then know what the radius is. How deep do I cut?
Jim, would you use as a spacer between your wood blank and the lathe? I saw you put another piece.
I have a homemade oak washer, so I have a little bit bigger than 1 inch hole, and then I run this through a drum sander to flatten it. And that's between the wood and the back end of the mandrel. That's so the mandrel doesn't stick out. I do not want metal sticking out of the end of this. Fact is, I want to be able to cut into this wood before I hit metal. So I just put a spacer to kick it out. And then as I cut more and more off of this, I'll put more washers in there to be safe. I don't want to hurt the lathe, basically. Oh, I forgot my joke. Y'all want to laugh before or after I tell you? How many of y'all have to keep your hot melt glue in the refrigerator so it doesn't melt in your shop?
Will you pass around your bolt?
I can't.
Let me put it up here real close.
Just stand before you do that.
Just for the record, when I'm at home, and I don't care if this thing flies off and whacks the wall, I'll touch it. And when it feels kind of hard, I'll start turning. That is probably not the best thing to do. Okay, the first thing I want to do is make sure this is running true. So I'm going to look at that divot, and it's got a little bit of a wobble. I'm going to put a pencil mark on there. And then I'm going to put a pencil mark inside the pencil mark that I used from the compass. And it looks pretty good. So I'm happy that everything's aligned properly. And now I just need to turn a bowl here. I want to eyeball and set a depth gauge so that I don't go through the bottom, and my notes tell me to shoot for a 3/16 inch wall thickness. So I've got that set. And now come in 3/16. I don't have a lot of experience with hot melt glue, so I normally start kind of gently. There, I've set my wall thickness that I want. Now I'm just going to turn a bowl, and I'll take light cuts just so I don't stress that glue joint. I've watched probably a dozen or more videos, so everything I'm doing you can find on YouTube. And they all do exactly the same thing. They always have half the bowl inside and half the bowl out. You don't have to do that. If you want more of it hanging out, then you can do that. If you want less of it hanging out, you can do that too. There's no reason you can't have as much of that bowl in or out as you want. But I want to set my depth. like to use my normal calipers to measure that wall thickness, but I can't. They're too big to get underneath, so this is baling wire. Coat hanger works just as well.
Put it so you can see it in here. There you go.
I take it, this is a piece of baling wire, and I bend a piece that'll fit between the bottom of the bowl and my glue block, and then just bend the arm around. Coat hanger works even better because it's not as flimsy. Now I can measure the wall thickness. I'm actually kind of happy with that.
It looks good.
I keep getting lucky.
Yeah, it's not luck. Not that terrible.
I want to stick my finger in there. I broke myself of that habit, and I'm going to try really hard not to get back into it. I almost lost a finger once. Okay, I'm going to clean up the bottom just a hair and then call it good. That's not, that needs work, but I'm going to quit. Have any questions about what I've done? Critical thing is either measure or eyeball the thickness, the depth of your bowl, and set your gauge so you have enough wall thickness at the bottom. Set a line over here to tell you what your wall thickness should be, and then just turn a hemispherical bowl with those 2 points in mind. That's pretty much it. Now at this point I'd sand, clean that up, do whatever I need to. Now I want to face this off because it's not quite flat, and I want to flatten it out. This is where it gets interesting. Okay. I'm going to draw a line starting at the edge here, coming around to that edge so I can see how far to cut. And now I'm going to start on the outside and just start removing material.
Just to be clear, we're talking about the width of paper, right?
No, not here. I'm talking, let's give it some lip. This lip. This is what I want to start forming.
Okay.
But this gets exciting because I'm cutting half air and half wood. And here's part of the problem. A lot of people turn faster. When you're cutting air, they turn really fast. I'm not comfortable doing that with a hot melt glue joint. The paper joint I would. But the other problem is I tend to blow this backside out, so I have to take really light cuts, stay patient, okay? And then the last thing I need to do is come by and make this finished cut. I'm going to start on the outside and work my way up to that line and stop short of it and just remove material. If you have a small lathe, and I do all my work on a Jet 1220, almost all of my work on a 1220, this can get it to shaking a little bit. I turn it 800 RPM max. If I run it at 12, it starts vibrating. You could put a bigger block here to counterbalance this, especially if you have a much longer piece. You could also glue a piece on this back edge and then on the front edge to prevent it tearing out as you come around. I don't know if you've noticed, but I've got a big crack running through this, and unfortunately, it's on the back edge. I'm going to run this 850 RPM. I'm going to put some paper underneath so I can see the ghost as they come by. Take a light cut and stop before I hit that pencil line. Okay. Got a little tear out on this backside. I'm not going to worry about it. I should at this point go back and take little light cuts, or even it's 1500 RPM. I'll make just a light shearing cut. Okay, on the back side, and the piece I turned around, the same thing happened. There was this weak part in the wood, I caught it with the tool and it came flying off. Okay. It removed the tear out. Actually, this looks, it's not as flat as I want it, but I could hand sand that out. So now I need to cut and join the rim all the way around.
And if you notice, the only thing that goes on the other side of that tool rest is the tool. Fingers don't go over there.
Yes. Okay. Now, here's the hard part, because this edge of the bowl is actually part of the hemisphere. It curls under. So to do a really good job, I need to curl this under. I'm going to do that last. I'm going to start by making straight cuts, and I'm going to cut until I feel this other edge. And you might be able to hear it. I didn't hear it. I cut just a tiny bit too far. I cut just a little bit too far and left a mark over here. Can you see that?
Just barely.
I cut just a little bit too far, so now if I sand this, I can hide that mark. Then I can come at this edge, Remember when I passed that around, it was hemispherical and then it went straight down? You can see that flat spot here, but not here. So I'm gonna have to sand that out. And then I have a step here, which I always do, where I just now need to get my gouge in there and make a shearing cut coming this way, and that'll clean that up. Everybody on YouTube makes half in, half out.
What do they call that on YouTube?
Emerging mold. Okay. But there's no reason why this is the center. There's no reason why I can't put a quarter of this. The center goes the same place. I've turned it this side exactly the same way. And all I do is turn a quarter of a sphere here. Fact is, you can do a quarter, a half, 3/4, just whatever you want, using exactly what we've done here. And all you have to do is locate that point properly. Turn a good hemisphere here, locate that point, and you can put this bowl anywhere you want. You could make a series where it's coming out.
Oh, I see. Huh.
The accuracy you have to worry about is, I got a good hemisphere all the way around here, and that gave me a good uniform edge. The thickness of the edge here is pretty good uniform. I didn't quite get it right here, and that made it hard to judge when I had gotten just right where I needed to be. But I can clean this up with sandpaper. So, get a hemisphere that's pretty good, locate the center as accurately as you can. Take gentle cuts when you make this last cut, and I normally stop several times along the way. I'll cut, stop, and that way I don't cut too much. But if you do, you can always clean it up with sandpaper. And if it's really bad, turn the lathe on and hold sandpaper against this edge, and then hold sandpaper against this edge, and when it rounds those over, it hides the width. You can't tell. So you can make something that has kind of a weird rim, but you really can't see it that well if you round those over. And then the next thing is to cut this off, and I just use a pocket knife at home. Cut this off.
Another way to get rid of that hot glue, denatured alcohol. Put on there and it'll just pop right off.
Does anyone have any questions? I've got a couple more things to show you, not about this. Do you have any questions?
If I were going to try one, would you recommend using hardwood or softwood?
I would use hardwood. I use cedar because that's what I had around, and then somebody asked me to, I had 3 different blanks and they said use cedar. I thought I'll use cedar, but I prefer hardwoods for this. You can also use a much bigger glue block or glue board, and that helps with the stability. If you have a small lathe, this is too short. I really need this longer, but this is what I had available, and that's what was requested. If you have the harder woods, they're heavier, and the longer you make this piece, the more out of balance you're going to be. That's when you'll probably want to use a bigger, harder, heavier counterweight. And if you get the counterweight right, you can run this thing at 2,000 RPM on a small lathe. If you get it wrong, it'll throw the whole thing off. So be gentle. Okay. So that's the basic idea. Do you have any questions about what it took to get here?
Good job.
whole idea behind this is that if you could mount, think of a block of wood with a ball inside it, or a sphere. If you can mount that sphere so that the center of the sphere is on the center line of your lathe, you can turn part of the sphere, rotate it, and if you can get the center back online, and you can determine the radius of that original sphere, you can turn something and it will match. And you can turn it again and turn another part of the sphere and it will match the original. And that's how I made this. Hans Weisflog made this, and I saw it online. His was a box. I just made the shape. And the idea is, I screwed this on the lathe, took a 4x4. I didn't have a 4x4, so I blew two 4s up. And turned it. Actually, I turned it this way and got part of the sphere. Then I turned it this way and used the original sphere to tell me how to turn a flat spot this way. And then join in with the original part of the sphere. Then I turned it again. And now the rest of this was flat from the 4x4, but now I had these two ball-shaped things in there. So I added this to tip it over 2 times the original angle, and that let me turn this face. It's exactly the same concept as this, except a little more work. And the trick behind some of this stuff is figure out how do you mount this on there. And the hot melt glue has been a pretty good way for me to do it. It's worked out well. So if you take a look online and look for Hans Weisflog,
Say it slower.
you'll see a whole bunch of stuff like this. And
Can you repeat that name?
Weisflog, yeah, Hans Weisflog.
Can you spell it?
W-E-I-S-S-F-L-O-G. He has a lot of stuff like this, but at a much higher level. And these concepts are how I plan on trying to make some of those. I have a file of stuff that I want to copy. His is at the top of the list right now. And this is the kind of work that he was doing the last few years. I really admire his work. That's where I want to go next.
Amazing.